So in this example, let's find the lateral area and the surface area together. The first thing we're going to do is we're going to find the lateral area. And remember, the lateral area is equal to pi times r times L in a cone. So I need to be able to find the values of r and L. Well, notice here, I'm given the diameter of the circle. So how do I find a radius from the diameter? Well, the radius is half of the diameter r. So if this value is 12, this height or altitude is going to cut that in half. So half of 12 means that r is equal to 6 inches. Now, the other thing I need to locate is the slant height, or the L of this figure. The L is going to be right here. And again, to find this L, notice we have a right triangle here, where one of the legs is 8, the other leg I just found to be 6, and this is the hypotenuse I'm looking for. So using the Pythagorean theorem, 8 squared plus 6 squared should equal L squared. 8 squared is 64 plus 6 squared is 36. That should equal L squared. 64 plus 36 is 100, and that's equal to L squared. Take the square root of both sides, and I get L equal to 10. So now that I know R and L, the lateral area is just equal to pi times R times L. And this is just equal to 60 pi. I'm going to leave it exact now because I want to go find the surface area. And recall, to find the surface area of a cone is pi times R and then L plus R. So when we do this, we know all of these values. So we'll say the surface area is equal to pi times R. So pi times 6 times L, which is 10 plus 6. And so I get the surface area is equal to, in the front of the equation, is 6 pi times 16. And 6 times 16. So SA is equal to 6 pi times 16, which is 96 pi. And again, I didn't add the unit, but this should be inches squared, and this should also be inches squared. And these are what we call exact answers. If I want their approximate values or their estimates, for the lateral area, I would do 60 times 3.14, and I get 188.4 inches squared. And for the surface area, I would do 96 times 3.14, and this is equal to 301.44 inches squared.